Good morning, dear students. So, in the last video, we have already started with the new chapter matrices. So, let us have a brief recap of the chapter. So, we started with definition of matrices. As I told you, it's a rectangular array of numbers or functions. Basically, arranging the data, it can be number or functions in rows and columns. Then order of a matrix, as I told you, if there are m rows and n columns, the matrix is said to be of order m by n. Then we did types of matrices. So we had gone through the definition of different types of matrices with examples. Then operations on matrices, the fundamental operations. First one is addition. So we discussed addition of matrices and properties of addition. So one important feature is if you want to add any two matrices, the order should be same. That is, number of rows and columns of the first matrix should be same as number of rows and columns in the second matrix. Then scalar multiplication, so which is defined as k into a, where a is the given matrix and k is any scalar quantity. So what you will do is you will multiply each entry in the matrix with a given scalar k. Then multiplication, again in multiplication I told you that if you want to multiply any two matrices, the order is very important. As in the normal multiplication, a into b is not equal to b into a when it comes to matrix. So if you are doing a into b, the number of columns in a should be equal to number of rows in b. I repeat, the number of columns in the first matrix should be equal to number of rows in the second matrix. Then only you can multiply the given two matrices A and B. So here there is one example. So this is a solved out example in your textbook, but this is a very important example. So in this example you are proving the associative property of matrix multiplication. And along with this, I will explain you matrix multiplication once again, so that it will be helpful for you as well. Okay, so here you are given three matrices, say A, B and C. So A, you can see it is having 3 rows and 3 columns, so which is of order 3 by 3. Now when it comes to B, it has 3 rows and 2 columns. When it comes to C, it has 2 rows and 4 columns. And you are asked to show that AB into C is equal to A into BC. So here first let us solve the left side of the equation AB into C. So let us consider the matrix A and B. So A, you can see 1 1 minus 1 2 0 3 3 minus 1 2, that is matrix A. And matrix B, we have 1 3 0 2 minus 1 4. So here what you are doing is, first you will fix the rows in the first matrix. So let us fix the first row, and with first row you will multiply the entire column in the matrix B one by one. That is what you are doing. Then you will move to second row, you will multiply second row with the columns in B. Then you will move to third row, and third row is multiplied by each column in B. So let us stick on to first row of matrix A. So you have first row 1 1 and minus 1. So this you will multiply with 2 columns of B. Okay. So first row into first column, first row in A into first column in B will give you the element in first row, first column. Now first row into second column. So first row in A into second column of B will give you the element in first row, second column. Now there are no columns in B, so we will move to second row in A. Now second row is multiplied with first column in B, which will give you the element in second row, first column. Again second row is multiplied by second column in B, which will give you the element in second row, second column. Now we will go back to third row in A. Third row is multiplied by first column in B, which will give you the element A31, that is third row, first column. Then third row is multiplied by second column, which will give you the element A32. Okay, so let us do the multiplication. So first row is multiplied with first column. So you have 1 into 1 plus 1 into 0 plus minus 1 into minus 1, which will give you 2. Now moving to second column, 1 into 3 plus 1 into 2 plus minus 1 into 4. So 3 plus 2 minus 4, which will give you the element 1. Okay, now you will go to second row. So 2 into 1 plus 0 into 3 plus 3 into 1, which will give you 2 plus 0 minus 3, which is equal to minus 1. Now second row into second column, 2 into 3 plus 0 into 2 plus 3 into 4, that is 6 plus 0 plus 12, which will give you the element 18. Now third row into first column, so that is 3 into 1 plus minus 1 into 0 plus 2 into minus 1, which will give you 1. Now third row into second column, so 3 into 3, 9 plus minus 1 into 2. So 9 minus 2, 7 plus 2 into 4. So 7 plus 8, you will get 15. So that is A into B. Now you are multiplying A into B with C. Again you can see in A into B you have 1, 2, 3 rows and 2 columns, and in C you have 2 rows and 4 columns. So the condition is number of columns in first matrix should be equal to number of row in the second matrix. Here you can see 2 columns are there in first matrix and 2 rows are there in second matrix. So matrix multiplication is defined. Now let us do matrix multiplication of AB into C. So in AB you have first row. So first row is multiplied with first column. So 2 into 1 plus 1 into 2, which is 2 plus 2, which will give you first row first column element 4. Now you have 3 more columns. So each column you will multiply with first row. Now moving to second column. So first row into second column, 2 into 2 plus 1 into 0, which will give you the element in first row second column. Now you will multiply first row into third column. So 2 into 3 plus 1 into minus 2, that is 6 minus 2, 4. So first row third column. Now first row fourth column. So 2 into minus 4 plus 1 into 1, which will give you minus 8 plus 1, which is minus 7. Now first row is completed. Now moving to second row. Second row and first column. So you have minus 1 into 1 plus 18 into 2. So minus 1 plus 36, which will give you 35. Now second row into second column. So minus 1 into 2 plus 18 into 0, which will give you minus 2. Now second row into third column, that is minus 2 into 3 plus 18 into minus 2. So you will get minus 3 minus 36, which is minus 39. Again one more column is left. So second row is multiplied with the last column. So 1 into minus 4, sorry, minus 1 into minus 4 plus 18 into 1, which will give you 22. Now moving to third row. Again third row is multiplied by 4 columns. So third row into first column will give you 31. Third row into second column, which will give you 2. Now third row into third column will give you minus 27, and third row into last column will give you 11. So this is AB into C. In first row you have 4, 4, 4, minus 7. Second row you have 35, minus 2, minus 39, 22. And last row you have 31, 2, minus 27, 11. So that is your LHS AB into C. Now let us do A into BC. So first you will start with BC. So this is matrix B and this is C. Again you can see 3 rows are there, 2 columns are there in the first matrix. So 2 columns are there in the first matrix, 2 rows are there in the second matrix. So number of columns of first matrix is equal to number of columns in first matrix is equal to number of rows in second matrix. Therefore matrix multiplication is defined. Now let us do first row into first column. So 1 into 1 plus 3 into 2, which will give you 1 plus 6, 7. Now first row into second column. So 1 into 2 plus 3 into 0, which will give you 2. Now first row into third column, 1 into 3 plus 3 into minus 2, which will give you minus 3. Now first row into last column, so 1 into minus 4 plus 3 into 1, which will give you minus 4 plus 3, minus 1. Now moving to second row. Now second row is multiplied by all the 4 columns. So second row into first column will give you the element in second row first column. Now second row into second column will give you the element in second row second column, that is 0. Then you have second row into third column, minus 4. Second row into last column, that is 2. Now moving to third row. So third row into first column, minus 1 into 1 plus 4 into 2, minus 1 plus 8, which is 7. then third row into second column. So minus 1 into 2 plus 4 into 0, minus 2 plus 0, minus 2. Then third row into third column, minus 1 into 3 plus 4 into minus 2, which will give you minus 11. Again, third row into fourth column. So minus 1 into minus 4 plus 4 into 1, which will give you 4 plus 4, which is 8. So this is BC. Now you will do A into BC. So you can see this is matrix A. Again, 3 rows and 3 columns. So number of columns in A, that is 3 columns, is equal to number of rows in BC, 3 rows. So you can multiply. So first row into first column will give you 4. Again, first row into second column, 4. First row into third column, again 4. And first row into fourth column, minus 7. Now second row is multiplied with all the 4 columns, which will give you these entries. Again, third row is multiplied with each column, which will give you the entries in the last row. And you can see this is same as AB into C. This is what we obtain when we find out AB into C. So A into BC is same as AB into C. Therefore, associativity holds. Hope you understood matrix multiplication and the property as well.